What I want to look at today is the generic forms of the hyperbola. How do you plot them, and how do we graph them, and how do we get some of the important information as far as like asymptotes and stuff are concerned out of it. There's a couple of setups for it. Again, it's about A's and B's and C's and stuff, and going from there. Does anybody know what a hyperbola looks like?
It looks like
Woo. Exactly. It looks like woo.
no, like cup.
It's up like a cup and down like a frown at the same time.
That's what I did.
I know.
Kind of.
So it's kind of like you're happy and sad at the same time. You're melancholy. Is that right? Melancholy? Is that the right vocab word? Nope.
Yes, I loved it.
Just making stuff up. Anyway, here's what happens. It looks crazy. What happens here is, again, we are going to have two generic forms. Two generic forms. X squared over A squared minus Y squared over B squared is 1. Or Y squared over A squared minus X squared over B squared is 1. In this case here, the major difference of telling that it's going to be a hyperbola is because there's a subtraction symbol. Everything else we've dealt with so far has always been addition. So immediately when you see a subtraction symbol with x squared and y squared on the same side, go ahead and you can say that it's going to wind up being a hyperbola. When we had the ellipses, the a squared placement decided how it was being stretched, whether it was up and down or stretched left and right. In this case, it's whatever term comes first. If the x squared comes first, it's going left and right. So this is your left and right. And if y squared is first, it's your up and down. Okay. That's basically what's going on in here. Again, there's going to be a focus point. There's going to be a vertex. There's going to be a co-vertex we're going to mess around with here as well. It is a very systematic way of writing these things out and plotting them, just like we did with the ellipses, and I'll write this up here as well. I'll let you write that out real quick. So here's what happens. One of the things I want you to look at here is just kind of look at the graph itself. Notice it's nothing more than it's kind of like a double-sided parabola. You still have a focus and a vertex. What they're not calling this point here, the B value, they don't call it a co-vertex. It really isn't a co-vertex, but you'll sometimes hear me refer it as that because we treat it that same way. What I want you to notice, though, is that you see how they're forming rectangles? When they form these rectangles, you get through the vertices of the rectangles, the diagonals here, you get your asymptotes. And one of the things that we're going to have to label out here is how you find the slopes of those. And it's nothing real crazy because it's the generic form for this. Let me show you. When you're working with the x squared term first, it means your left and your right. Your how do I say this? Your vertices, your vertex, since it's centered through the origin, is going to be at your a, comma 0, and your negative a, comma 0. I'm still going to kind of call it a co-vertex, and again, it's going to be at 0 and b, and 0, negative b. And your focus, since it's stretched left and right, it's going to share the same y value. So your focus then is going to be at c comma 0 and negative c comma 0. And with the hyperbola to find c, we're just using Pythagorean theorem. Okay. Which leads you to your asymptote. Your asymptote for this one is always going to be plus or minus b over a when it's stretched left and right. Times x. That value of x, because it's going through the origin, they're writing it out in terms of y equals mx plus b. That plus or minus b over a is that slope. And when it's stretched the other way, it's just flipping them around. So let me walk you through how you set one of these things up. Like I said, there's not a lot of real crazy math involved. And once you draw it out once, you're going to find that graphing these things, especially when they're centered through the origin, are really quite simple to work with. Okay? They're very quite simple to work with. So let me show you an example. We'll refer back up here then. I'm not going to use graph paper because that's just a waste. But we're going to do this hyperbola here. I'm going to draw out the hyperbola that has the equation 4x squared minus 9y squared equals 36. And what I'm going to do is draw it out and label everything. And what I mean by label everything is very similar to what we did with the ellipses, where we listed out all the different vertexes and all that kind of fun stuff. Now, in this case, you're being told that it's a hyperbola, which means one side has to equal 1. So how do I get the 36 to equal 1? Don't say subtract 35.
Divide by 36.
Right. So first thing you're going to do is divide everything by 36. That'll give you your fractions. And lo and behold, you get x squared over 9 minus y squared over 4 equals 1. Now we know it's a hyperbola, and if it's the x squared term comes first, that means it's going to be opening left and right. So just like I did with the ellipses, I'm just going to kind of make sure I do this real quick, just so I make sure that my graph looks like that when I get to it. Excuse me. So a squared is 9, b squared is 4. So a is going to be plus or minus 3, b is plus or minus 2. So c squared is going to be 9 plus 4, which is 13. So c is plus or minus the square root of 13. Yes, sir?
A is always the large number, right?
No, with hyperbolas, a squared is always the first one. With ellipses, a squared is the larger number. And hyperbolas, it's just whichever one comes first. Okay? That's where things can get a little messy if you mix them up. No, not necessarily with the hyperbola. A squared is just decided by if it comes first. That's all it is. So here we go. All we gotta do is just draw up a grid. I know that my vertex is going to be at 3, 0, and 0, negative 3, 0.
Couldn't you just put plus or minus 3, 0?
No, I don't want you to get in the habit of doing that. And we talked about this last week. I don't know if you were here for that.
I was.
The reason I don't want to say plus or minus 3, 0 is because when we get into the ones with the shift, with the h's and the k, it's not going to be that clean. I just want you guys to get in the habit of listing out the two separate ordered pairs. 1, 2, 3, 1, 2, 3. The b value, what we're going to kind of call the covert vertex, is then at 0, 2, and 0, negative 2. So far, so good? Create the rectangle. When you create that rectangle, you can now put the diagonals in, and when you place your diagonals, those become your asymptotes. Okay. Last thing I have to do is plot my C value. My C value was the square root of 13. The square root of 13 is bigger than the square root of 9, but smaller than the square root of 16. 3.5-ish. So here's 4, so we'll put it about here.
Would the slope of those lines be 3/4?
I'm getting to that, because that would be it, because you've got your left and right, so it's going to be opposite, it's going to be B over A, plus minus B over A, yeah. All you have to do now is hug the asymptote, go through the vertex, hug the asymptote. Hug the asymptote, go through the vertex, hug the asymptote. That's it.
You don't want actual points.
No, because you're going to be bounded because of your asymptotes. That's what's nice about the hyperbola. You don't have to really worry about it like you did on the parabola, because you don't have an asymptote on the parabola. Here you're bounded. Okay. So now all I have left to do, like you said, is that our asymptotes will be at plus or minus 2/3 x. And I'm done. I've labeled all the important stuff, and I plotted it. Like I said, they look weird. It looks like it's going to be a real complex thing to do, but really quite easy. Let's try it out. Oh, 2/3, remember the asymptotes, or the equation of the line for the asymptotes is always for going left and right. It's always going to be plus or minus B over A. If it was going up and down, it would be plus or minus A over B. Try it out. So right off the bat, can you guys tell me which way this one's going? It's going up and down. Yep, it's going up and down. So this one's opening up and down, which means then my vertex, will my vertex be at 0A or will it be at A0? 0A, because it's up and down. Remember, these are centered at the origin, so it's going to be at 0A. It mirrors the same idea of the ellipse, since it's opening up and down with the center through the origin. Then that co-vertex would be at B0, opposite of B, negative B. So again, we just start by labeling. A squared is 100. That means A is plus or minus 10. B squared is 75. So B, was it plus or minus 5√3?
Yeah.
So C squared is going to be 175. So C, the square root of 175 would be 5√7. Okay. From there, I know enough stuff. I know that I'm going to be going up and down. So my vertex be at 0, 10, 0, negative 10. that co-vertex, 5 root 3, 0, negative 5 root 3, 0. Square root of 75 was more than 64, but less than 81, so 8.6? Sure. I've plotted both my vertex and that co-vertex. What do you think I'm going to do now? Draw the rectangle. Gives me asymptotes. Plot your focus. Focus was at square root of 175. Well, that's bigger than 12, or sorry, it's bigger than 13, but smaller than 14, right? Sure. So here's 10, 11, 12, 13, 14, so we'll call it here. Hug the asymptote, go through the vertex, go the other way. Bomber. And then your asymptote equation, it's A over B, so it'll be 10 over 5 root 3 x, so that is what? 2 root 3 over 3 x. Thank you. I had it here at plus or minus, but I forgot to write it down. Thank you. And there's the slope. Yes. Yes. You don't have to do that after you get to calculus. You're not in calculus. At least sometimes they do. I don't remember. Okay? Again, like I said, what's that? Like I said, I can't imagine these are going to be horribly scary bad with this. The worst part with some of it's going to be when you have to write the equation out. It's usually one of those. Or you know what? Let's do that. No, let's do that now. I thought about it for tomorrow, but then I realized that on Thursday it's 20 minutes. We can do something else.
Because we don't good one, Jason. Good one, Lisa.
Yes, sir.
Is that equation that we do plus or minus A over B or plus or minus B over A? Is that the
For when it's up and down, your slope is A over B. When it is left and right, it's B over A.
that's the research one.
So let's go the opposite direction real quick here, guys. Let's talk about having a focus and a vertex. Or sometimes you'll have a vertex and that co-vertex or whatever. All that fun stuff. They don't, I do. There is a name for it, I forgot what it's called. And every year I always forget to look up that name. So I will look up the name. So if we look at this right here, if I have a focus at -4 and 4 and a vertex at -1 and +1, is this opening left and right or up and down? This one's going left and right. Okay, this one's going left and right. And the reason why it's doing that is because the focus is here and your vertex is here. Okay? So I know that's what's happening. So if it's opening left and right, is this x squared first or y squared first? X squared. X squared. So I know it's going to be an x squared minus y squared equals 1. Now I just got to figure out what A and B are.
A would be 1.
A is 1. Very good. So A is 1, so we square it, you get 1. Now, I know that C is 4. Everybody okay with that?
Yes.
So what's C squared?
16.
16. Now, in order to figure out what b squared was, remember, c squared equals a squared plus b squared.
And a minus 1.
What's b squared? 15. Hyperbolas aren't too frightening, are they?
You don't have to rationalize it, right?
No, you just have to find out what b squared is. You don't have to do anything else.
Oh, yeah.
You don't have to do anything else. Okay? Let me give you a few of these to try tonight. Let's do. This is on what? A 619. So on 619, let's do. We'll do these. 619.
Thursday.
All right. What'll happen with the first grouping when you're graphing them? Please do just like we did in class. Label out everything. Draw the rectangular box. Put in your asymptotes. Label it out. Yes, sir.
This one sounds like your new homework. I don't know what to call it. Yeah, your homework choices.
Why is that? Well, if you can do 4 of them, you can do 50 of them. What's the point, right?
Right.
Stick with this. I mean, seriously, you start thinking about it. Because if you look at the other problems that are in here, they're asking you to just to write it out in standard form. Whatever, you get 1 side equal to 1. Ooh. Identify the parts. Well, if you got to identify the parts, you might as well take it a step further and graph it, because you got to do it anyway.
Yeah, it's more concise.
So, but yeah, what we'll do on Thursday is I'll start giving you guys the combination problems. Well, you'll have to identify which conic it is and go from there. That's when things start to get messy. All right? Yeah.